All right, welcome to 3.6 log properties. So we did a lot of stuff with logs before. For example, we did log of base b of c equals a, and we know this is equivalent to b of a equals c. Those are equivalent. We know this. We've done this. We accept this. But let's add a little twist. Log of, let's say, 7 of 7 cubed equals what? Equals what? So to solve it out, we label it B, C, and A. And you convert it over here, 7 to my A equals 7 cubed. And you see A equals 3. My result is 3. What does this mean? And we see, how many 7s do you need to get 7 cubed? I need 3 7s. So this equals 3. Let's do another one and see how this impacts what we have. Let's say log base 2 of 4 to the 5th equals what? See, what is it equal? So B, C, and A. 2 to the x equals 4 to the 5th. Now here, I'm going to do some exponent rules that you might have forgotten. Maybe you remember it, but I don't want to do 4 to the 5th. That's kind of big. 4 to the 1st is 4, then 16 to 64, then 256. It's getting big. I mean, you can do it. 10, 24. You can get it, but then like how many 2's go into that is kind of hard to do. What you can do instead is 2 to the x is equal to, what's 4 in terms of 2's? 2 to what power is 4? It's 2 squared to the 5th. And exponent powers, exponent rules, if you have exponent to the exponent, you multiply those. And this, I'm just glossing over, this is theory. So we have x equals 10. So we have 10 right here. This kind of shows us a glimpse. We have this example right here. Now let's say, what if I had log base 7 of 7? How many 7's go into 7? How many 7's do I need to multiply to get 7? Only 1. Over here, I have log base 2 of 4. How many 2's do I need to multiply to get 4? I need 2. So we're starting to see a glimpse of the first property. The first thing we care about with logs is, I see right here, if log base 7 of 7 is 1, and I put that cubed inside, my result is 3. I brought that number out. But I can't always bring that number out, because this 5, I didn't just bring out and get answer 5, I got 10. But I see over here, log base 2 of 4 is 2. So that result is 2. And if 5 and 2 relate, if I multiply them, I get 10. This confusing interaction is actually the first property, the exponential property of logs. The exponential property, where log base b of a to the r. Do you want to write it like this? Yes, I do. This is equivalent to if I bring the r out and multiply it with the log base b of a. This right here, if I brought the 3 out, 3 times log base 7 of 7, which is 1. So 3 times 1 is 3. If I brought the 5 out, the log gave me 2. So 2 times 5 gives me 10. This is interesting, and we will use this oftentimes to simplify logs so that we go actually from this one back to here. A lot of times we want to simplify it to go back. So we'll try it out, 2 examples both ways. Log base 4 of 16 cubed. Let's solve this. Let's evaluate this. I don't want to do 16 cubed. That's very big. And this is also used for if I had variables inside. So this, I want to convert it to 3 times log 4 of 16. 16, a weird 16. So this becomes 4. Over here now, I want to solve for this. I can't really solve for it. We could solve for it in our heads, but I still want to use our little example. So 4 to what power is 16? How many 4s multiplied to 16? That is 2. 3 times 2, which is 6. So log base 4 of 16 cubed is 6. And not the other way around. Let's say we want to simplify. Simplify this. I have 7 log 4 of 10. I want to simplify this. I can't really do log base 4 of 10 because 10 is not a clean exponent of 4. So I must bring this now inside. Log 4 of 10 to the 7th. And you don't have to expand it out unless it asks you to expand it out. So this is my simplified version. It's all written neatly as log base parentheses. Nothing outside of that. And this will all be combined later in a future example as we do more. So exponent property is this rule right here, where these are interchangeable. I could bring the exponent out and bring it back in. Out to in to out. Next up, the sum property of logarithms, which is, let's take for example, log base 2 of 4 plus log base 2 of 8. What is it equal? Let's find out. How many 2's go into 4? I have 2. How many 2's go into 8? I have 8. Not 8, I have 3. This gives me 5. Log base 2 of 3, and then it's going to be 2, 3, and 5. I could solve it out, simplify it, get 5. But 5 equals log, keeping the same base, of what? How do I get this? And we do our BCA tactic to get 2 to the 5th equals what? 32. I got my number of 32. I reverse engineered and got 32 should go inside here. And I see, how does this 32 relate to the 4 and 8 I had before? I see 4 times 8 is 32, which tells us the sum property of logarithms, where if you're given 2 logs of the same base, log base b of a plus log base b of c, this gives us log base b of ac. They're being multiplied together. And we will use this to simplify logs just like we had before. I want to simplify it, I want to tuck it all in. And also, after that, we're going to combine these properties to then solve for variables. So do one quick example. Let's say I had log base 9 of 4 plus log base 9 of 12. I can't simplify this. I can't simplify this. If you can solve it out, you can just solve it out. Like if it was 9 and 81 or 9 and 9, you can just simplify it. But this, we see 4 is not a clean exponent. Like we can't do 9 to a power to get 4 or 12. So we now combine it. Log of 9, 4 times 12 is 48. And we see it's one clean log. Log base parentheses. We want to condense it down into one log. Now, a difference property of logarithms. Log base b, actually we'll use the same, a similar one before, 2 of 4 equals, wait, no, not equals, minus log base 2 of 8. 2 minus 3 equals negative 1. So log 2 of what equals negative 1? What is this c? We once again apply our exponents. 2 to the negative 1 equals c. So 1/2 equals c. And how do I get this 1/2 from 4 and 8? If the first one before, if sum is multiplication, this one, by the comparison between mathematics, and we see like addition, subtraction, multiplication, division, we said this one is division. So our property is, once again, same base, log base b of a minus log base b of c equals log base b of a over c. 4 divided by 8 simplifies to 1/2. And now this combines our 3. So we have this difference rule. I'll write them all over here. And our log b of a r equals r log b of a. These questions have 2 steps to it. The first step will be to simplify, and the second step will be kind of to solve. So let's just make up a random thing right here. 3 log 2 5 plus 2 log 2 of 7. So first off, I want to combine it, but I see I have this addition. But the addition only applies if I just have plain logs. Logs of b and a. Logs of b and c. But there's 3 and 2 in front. So you must first use this exponent rule, convert it to exponent, bring that r inside, and then I apply these rules. So it's log base 2 of 5 cubed plus log base 2 of 7 squared. Now I could then apply this rule and get a, which is 5 cubed, and c, which is 7 squared, and combine it to get this one nice log of log base 2 of 5 cubed times 7 squared. As before, your final result should be log base parentheses. It can be kind of gross inside, but we can leave it like this for now. I'll tell you when I want you to solve for an actual value and how many decimal points to leave it in. We'll do one more and introduce something as well. ln. You might have seen ln in the homework. You might have recognized it in class. But ln is just log base e. We use e a lot, and ln we just simplify it to just this. Also, one thing as well, log on your calculator is equal to log base 10. These are 2 key things we'll learn about in the future, but I just wanted to hold on to this. Not be too scared if you don't see a base. If you don't see a base, think that's like a base. Like, you want the same. If they both have nothing, you can add and subtract them. If they're both ln, you can add and subtract them. So 2 ln of 5 minus ln of 4. We want to first bring the 2 in. So ln of 5 squared minus ln of 4. Let me just cross that out. So I have ln of 5 squared over 4. Nice. Okay. Now this takes the next step in our homework, but I'll go over kind of a problem that helps us with the homework if you still have trouble with it. So step 1, I said before, is simplifying to this. Step 2 now is, what if I have an equal sign? What if I now have a variable and I want to find out what this value is? Log of 2 of x plus log 2 of x plus 2 equals, let's say, 3. Will this work out nicely? Let's say 24. Log base 2 of x plus log base 2 of x plus 2 equals 24. Once again, we just treat our properties as our goal. We want to get a single log, so you simplify it as much as possible. And we'll see how solving it makes a lot more sense once you simplify it. Log base 2, we combine these two because they're both base 2. X times x plus 2 equals 24. Oh, this will not work. Let's do 4. Do 4? Yeah. No, not 4. Let's do 3. 3. Sorry about that. So I have this value. I'm going to simplify the inside a bit more. Log base 2 of x squared plus 2x equals 3. How do I solve for this? I don't like that log there. So I'm going to get rid of the log by doing our rule of b, c, and a. 2 cubed equals x squared plus 2x. 8 equals x squared plus 2x. And all of a sudden, we see a problem we can solve. If you have x squared, anything greater than x, like x squared, we must get it equal to 0. So 0 equals x squared plus 2x minus 8. And now all of a sudden, we have a quadratic we can solve for. I'm going to factor it out, get x plus 4, x minus 2. And x equals negative 4 and positive 2. So I have two values x. And like what we did before, you must check your values. So my original function was log base 2 of x plus log base 2 of x plus 2 equals 3. If I have x equals negative 4, is that possible? Can you do log base 2 of negative 4? Does this work? What is our domain of log values, of log functions? Our domain of log functions, as we first learned it, because log functions are inverses of exponentials. And in exponentials, our range cannot be negative. Therefore, in logs, our domain cannot be negative. Doing a log of a negative will not work. It will be undefined. Similar to if you did 1 divided by 0 or the square root of a negative. These are a third undefined value. This does not work. You can't do the log of a negative. Therefore, this negative 4 gets canceled out and x equals 2. So now we see kind of the encapsulation where all the math we did with logs, we tie it back and we can do some more stuff with it. You will have questions like these in the future. The next topic, I'll probably do a lot more review questions with both interest, with the log stuff, and the last little bit of logs that we want to do, which is this and like some word problems. But here are now 3 topics. If you have any questions, once again, feel free to email me. Feel free to show up during breaks. Let me know. But yeah, hope studying goes well and good luck.